Welcome to challenge assignment 2. The task for this assignment was to build a home monitoring system that detects the presence of fire, any burglar activity, and also responds to a doorbell press. In this task, I will be using the MSP432 Launchpad kit along with the Educational Booster Pack to demonstrate the functionality. The approach used for implementing this task is the static preemptive scheduling. That is, the tasks have been given static priorities. The detection of fire is of the topmost priority, followed by the detection of burglar activity. A doorbell press is a periodic task, and it is every time triggered when the user presses the doorbell, and it has the lowest priority. The watchdog timer functionality has also been incorporated for the reliability purposes, and clearing the watchdog timer for proper functioning of the system is critical, and hence that is given the topmost priority. Let me take you through the code that implements this functionality. First of all, I will be holding the watchdog timer and getting my system initialized. For the system initialization part, I will be initializing first of all the ports that I used. I have two buttons. The button 1 acts as the doorbell press, and the button 2 acts as a switch for activating or deactivating the burglar check module. So I will be using the interrupt functionality for both of these buttons. The doorbell press acts as the interrupt on the port 5, and the switch press acts as the interrupt on the port 3. Post this, I will also have a RGB LED on the Educational Booster Pack, whose color will denote the status of the burglar activity module, whether activated or deactivated. So I will be using port 2 of the MSP432 microcontroller to indicate the status of this burglar check module. In case it is activated, the light should be red in color. If not, it should be green. Post this, we also have a buzzer on the educational booster kit that will give different tones for the burglar alarm, for the fire alarm, and for the doorbell. So we will be using a PWM signal, that is a pulse width modulated signal, from the port P2.7 as an input to the buzzer. The port P2.7 gets its signal from the timer A module, and timer A0 module, and we will be thus configuring the timer module as well. The timer will be counting upwards from 0, and the output mode is set to reset set. We will be changing the values of the timer registers for giving different frequencies to the buzzer. Also, we will be operating the system at 6 megahertz frequency, and the power settings of the system are chosen such that the power utilization is minimum. The watchdog timer functionality has been incorporated, and it will reset the system every 1 second. Also, we will be using the system tech module in order to generate an interrupt every 916 milliseconds in order to clear the watchdog timer count. The Educational Booster Pack has a light sensor that will detect the presence of fire in case of a high intensity light. We have a I2C module that will communicate between help in communication between the light sensor and the MSP432 microcontroller. Hence, we will be first initializing the I2C module as well. The light sensor acts as the slave, and the microcontroller acts as the master. The microphone on the Educational Booster Pack will give the analog signal of the sound in the surrounding to the microcontroller. In order to process this sound signal further, we will have to convert into a digital format. We will be using the ADC in order to do so. The ADC has been configured to give a digital signal of 8-bit resolution, and also it will be operating in the single channel, single conversion mode. We will be using the analog signal on the A10 port. That is, we will be using the port P4 pin 3 to act as the input for this ADC module. Also, we have configured the system to not sleep once it wakes up from the interrupt service handler. I will be using universal flags for detection of the burglar activity, for the detection of fire and the doorbell press. Also, I have a burglar act as a global flag that will indicate the status of the burglar check module. In order for power optimization, I have initialized all the unused ports. Now I will explain how my main function executes. First of all, I will be checking for any fire detection. As the fire detection is the highest priority task, no other task can preempt to it apart from the task of clearing the watchdog timer. Then, first of all, let me for modularity purpose, I have kept the functions in separate files. Let me take you to the fire.c file. In the fire.c file, I am resetting, I am checking the value of the light sensor, and if it exceeds the threshold, I am setting my global fire flag to 1, and also as the buzzer will have to play the fire alarm, I am uh, uh, enabling the timer module, and I'm asking my system to play the fire tone alarm. The fire tone alarm should be reset only on system reset, that is, it should stop only on system reset. After that, if the burglar check module is activated, then the burglar check function should be called, and in the burglar check function, first of all, we will check if the digital value of the sound is higher than the threshold. If it is, we will enable the timer module in order to play the burglar tone, and also we will set the global burglar flag to 1. Post this, we will check if the doorbell was pressed by the user. In case the doorbell was pressed by the user, we will play the doorbell tone. The doorbell tone and the burglar alarm tone have been broken down so that for each iteration, the fire check activity can be checked, and for the doorbell, the burglar activity can be checked. I have implemented preemption such that before playing the doorbell tone or the burglar alarm tone, I will always check if the flag for the higher priority task has been set. I also have two interrupt service handlers, one for the switch of the burglar module activation deactivation. In this module, I will check if the module was already activated, then I will deactivate it, and also if any burglar was previously detected, I will the kit will be playing the burglar alarm tone, and hence I will stop the timer. Also, I will if the burglar check module was previously deactivated, I will activate it by setting the burglar act flag to 1. In the doorbell ISR, I will be first checking if the higher priority tasks of fire and burglar were detected. In case they were, I will activate the timer module and set the global doorbell flag to 1. I will set the duration of the bell also to 0. Because I want to monitor that the doorbell is being played for 2 seconds. So this is how the main function executes. I also, as I mentioned earlier, I have a SysTick interrupt service handler that clears the watchdog timer. Let me build the code and enter the debug mode and see how the debugger helps us in verifying whether the code works as expected. I have set a breakpoint at the interrupt service handler for the in the interrupt service handler for the doorbell press. I will let the code run now and see if the control passes to the interrupt service handler of the doorbell press. I will press the doorbell button on the kit, and we see that the control has been passed to the doorbell press interrupt service handler. I will now let the code run. I will before that I will monitor that my doorbell tone is being played for 2 seconds. For that purpose, I will set a breakpoint at the start and the end of the doorbell global flag, as in where the flag is set to 1, and where the flag is set to 0 after the doorbell has finished playing. I will let the code run. We observe that the doorbell 1 has been detected. Now I will reset the counter. I am using the count event clock cycles to count the number of clock cycles uh, for counting the time duration of the doorbell press. I'll let the code run. So this is the place where the doorbell flag was set to 0, that is the end of the doorbell. Now that the doorbell flag is set to 0, that means the doorbell has finished its execution, and you can see the number of clock cycles over here. It is very close to the a number of clock cycles that occur in 2 seconds for a 6 megahertz frequency system. This shows us the dynamic measurement feature of the Code Composer Studio. In order to demonstrate the precompiled optimization feature of the Code Composer Studio, I will rebuild the code and we will check for the advices that the optimizer assistant has to offer. It will appear in the advice window, the Code Composer Studio. Now that the build is complete, we see that we have an optimization advice for setting our optimization speed to this is the current optimization speed, and the suggestion is to set the optimization speed to the level 3 and we to run the analysis in order to find the best possible fit for us. Then we have the ULP power advices. We will check the ones for the codes that we have written and not for the driver library files. Says that detected no use of low power mode, state changing instructions, and the use of the software delay loop instead of using the timer modules. So we will take care of this by introducing a sleep mode in our code. And for the software delay loops, I have not used them as it is already present inside an interrupt, and I do not wish to call another interrupt from one of the interrupts. I shall go to my burglar file and I will introduce a sleep mode post the start of the ADC conversion. I'll rebuild the code and let us see if our ULP advice still shows the same. As we can see, the ULP advice is built and the advice for no sleep modes used has disappeared. In order to demonstrate the implementation related optimization, I will take you through my code and examine how I have ensured that the system uses least power. I'm not running the system at its maximum operating frequency. I'm using 6 megahertz frequency as the usage of power is directly proportional to the frequency. Also, the core voltage for the system's usage has been used as the lowest voltage offered, that is 1.2 volts, that is V core 0. And also we are using the DC-DC regulator, and it is proven to be proven to give a better power utilization. Also, I am shutting down the timer module when it is not being used by using the MC stop, and hence I am restricting the supply of power to the timer module. This decreases my utilization of power. For the speed optimization, I have used the inline command for the tones, that is the burglar alarm tone and the uh, fire alarm tone functions have been inlined, that this reduces the calls to the functions and pushes onto the stacks and optimizes the speed. In In order to run the static implementation measurement feature, I will be using the optimizer assistant in order to analyze the speed versus size trade-offs. Uh, it has been observed that when we get the speed optimization, the code size varies. So this analysis will help us understand what is the best speed versus size setting offered by the IDE is the one which we can choose. Now that the optimization analysis is complete, we can see that at different optimization levels of speed selection, how much the code size will be. Post this, I will talk about the challenge that I faced during the implementation of this task. First of all, it was the preemption of the doorbell uh, with the fire and the burglar. So I broke down the doorbell tone in my main function, and I use the global flags in order to identify that the doorbell has been currently pressed, but still the user uh, can check for the fire and the burglar alarm, and the doorbell stays. The doorbell flag stays high till the till the point the entire 2-second period of the doorbell execution is not completed. Now I will show how the selection for the optimization levels for this project can be done on the advices, based on the advices. So I will select the optimization level to be 4, that is the highest optimization level, and the speed versus size trade-off as 3. I will rebuild my project. Now I will demonstrate the loading of the code onto the board. This is the MSP432 board that we will be using, and this is the double press button, the burglar alarm activate deactivate switch, the buzzer, microphone, and the light sensor. Let me turn on the system. I will now press the doorbell button and observe that the doorbell comes for 2 seconds on the stopwatch. Now I will turn on the burglar check module and we'll make a loud noise. So this is the loud noise that detects the burglar alarm. I will turn it off using the deactivate switch. Now I will focus a light and you can see that the fire alarm is being played. The fire alarm should be reset only on the system reset. I've resetted the system, and on the initial reset the burglar alarm should be deactivated and the green light indicates that. Now I'll demonstrate the preemption of the doorbell by the burglar alarm. I'll activate the module first and press the doorbell. We see that the doorbell has been preempted by the burglar alarm. Now we'll see the preemption of the burglar alarm by the fire alarm. Thus the preemption has been demonstrated successfully.